Okay, so in this video, we're looking at VCAA's 2021 Maths Methods Exam 2, Section B, and we're looking at question 2. So here we have 4 rectangles of equal width are drawn to approximate the area under the parabola from between 0 and 1. There they are. There you can see the shaded area. The heights of the rectangles are the values of the graph of y equals x squared at the right end point of each triangle is shown in below. So the width of each rectangle. So the width of each rectangle, where you can see down here when we look down here, when we look here, between 0 and 1 there's 4. So if there's 4 between 0 and 1, 1 divided by 4 is 1/4. So the width of each rectangle is 1/4. Get rid of those things. All right, the width is 1/4. All right, so state the area of the 4 rectangles as shown. All right, so the area of the 4 rectangles is, well, it's the sum of each of them. So the area, so this first one, so remember that's 1/4 there, this is 1/2, this is 3/4, and we'll need them because we need to know this height, and the height is that point right there. Now, the y value relates to the x squared. So the area, of course, the width down there, that's 1/4, times the height. Now, the height is the x value of that point squared. So in this case, it's 1/4 squared. Plus, right, so the width of each rectangle is 1/4 times, in this case, that point there, the height is, and the x value is 1/2, so it's 1/2 squared. Plus the next one, looks like 1/4, not a 3. So 1/4, and then that point there, of course, is 3/4 squared, plus, and again the width is 1/4, they're all 1/4, and times 1 squared in this case. All right, put that in your calculator, and when you do that, you get 15/32. All right. So now it says find the area between the graph of y equals x squared, the x-axis, and the line y equals 1. So now in this one, we're actually finding the actual area of it. All right, so the actual area of it is an integral, and that's the integral from 0 to 1 of x squared dx. All right, we need 2 marks. This one's straightforward, so I'll do it by hand. So that'll be x cubed on 3 between 0 and 1. Then when we substitute in, that's 1/3 minus 0 over 3, which is 1/3. All right, so a couple of things here on these bits before I move on to part D. Here, this one here, 2 marks. So you need more than just the answer, so we need the integral. All right, so you need to show the examiners or the markers where you actually got this 1/3 from. All right, now an interesting thing when you look at the examiner's report, for part A, they actually accepted 0.25. All right, now the reasoning behind that is that 0.25 is an exact value. It's not been rounded off. There's no other decimal places here that's been rounded off. So they did accept 0.25. For part B, also they accepted, what they accepted was 0.46, and we're going to get right this, 46875. Now, because if you figure out what 15/30 seconds is, it comes out to actually 0.46875, and that's it. That's where it finishes. It's not a rounded off. However, if people rounded that off to 0.47, then you didn't get your answers, because 0.47 is a rounded version of this. So they've considered these to be exact values because there's no further decimal places that have been rounded off. And of course, in part C here, 1/3, well, 0.3 is not acceptable because that's rounded off. It's 0.3 repeating. All right, and so looks like they're happy to accept decimals provided they're not been rounded, such as these two. All right, but of course you should, get your teacher's opinion on that, and examiners' reports and things like that. All right, next for part D. Part D, the graph of f is shown. So this is some graph. Approximate the integral from -2 to 2 of fx using 4 rectangles equal width, the right end point of each. All right, so we are going from there to there, and we want right end point. So what that means is that the rectangles we draw, the right hand end. Now I want 4, so between -2 and 2, they need to be a width of 1. Now I need the right end point. So this end here, that's not acceptable because it's the left hand end. All right, so let's get rid of that one. So what I need to do is I need to go and say there's that rectangle. Then between -1 and 0, that rectangle there is what I'm after. All right, then between 0 and 1, we need the right hand edge of my rectangle. So the right hand edge is going to be here. So I need that rectangle. And then finally, this rectangle here. Whoops, that's pretty bad. We're the right angle there. Now, this is where they've tried to be a little bit tricky here, because what they've asked you is to approximate an integral. They haven't asked you to find the area, they've asked you to approximate the integral. So in this case, because they've asked you to approximate a given integral, the negatives here are included. If we're looking at area, we would ignore that negative, but in this case, they've asked for a specific integral. So now area then. The width of the rectangle times the height of the rectangle. So when we look at this first one here on the left, the width is 1, the height is 6 plus. The next one, they're all width 1. The height of this one is 2. Width 1. Now the height of this rectangle is down here. Is its height, and that's -4. And then the last rectangle, its height is this one down here, which is -6. And so when you work that out, that's 6 plus 2 minus 4 minus 6, you get -2 square units. No, actually, we don't need square units because we haven't asked us for the area. They've just asked us for the value of the integral. All right, nearly tripped myself up there. All right, so a couple of things there to look at. Make sure you get your edge of your rectangle correct. And in this case, they've asked for the value of an integral rather than the area. Tried to be tricky. All right, part E. So part E, parts of the graph y equals x squared and y equals root x. So x squared is this one, root x. Okay, so they enclose this area, find the area of the enclosed region. All right, there's a number of different ways that you could find that area. One of them would be the area underneath the root graph. Which is 0 to 1 root x dx minus the area underneath the x squared, which would be this bit in here. So all of that minus this. All right, this is just one way of doing it. 0 to 1 x squared dx. Now you can enter that solely in your calculator. And remember, exact value is what we're after. And so the exact value is 1/3. All right. Now, for part F, now what we do is we transform the y equals x squared graph and make it ax squared, where a is between 0 and 2. It's not 0, but it could be 2. Find the values of a such that the area defined by the regions and these lines is equal to 1/3. All right, well, we already know one of those because we found this area to be 1/3. Now, the a value here for this one that we did there is, of course, 1. So from part E, so from E, we know that when a equals 1, the area equals 1/3. Now we've got to think, now what we can do is okay, I'm going to split it into two halves now. I'm going to say, all right, between 0 to 1 and then from 1 to 2. So our other possibilities, other possibilities is that, because it's not included, between 0 and 1, and then from 1, and a is up here, so I'm not including it, but we could have 2. All right, so what we are looking at then is we're looking at values of a. All right, so let us think about what might happen. And so if, let's look at this, that a is between 0 and 1. So if that's the case, what happens is that's a dilation and this swings out here. So what you end up with is for 0 less than a less than 1, what you end up with is a graph that looks like this. So you've got your square root graph, and here's our 1. And so that point there, of course, is 1, 1. But our x squared graph now goes like this. And so we're looking at the area between this area here is equal to 1. So in this case, what have we got? We've got the area underneath the root minus the area underneath the x squared. So in this case, we have the area between 0 and a under the root minus the area under the ax squared, and we want that to be equal to 1/3, and we want to use our calculator to solve that, get our calculator to solve that for us, and we want 2 decimal places, and so when we do that, our calculator would tell us that it's 0.77. All right, now the next bit is between a is 1 and 2. Oops, it's a little bit different. So if a is now bigger than 1, dilation, so what that's going to do is going to move this up. So our ax squared is going to go around like this. And so what we then end up with, so if here's the 1, so here's our a, for example, our root graph goes like this. And there's our our 1, 1. But our x squared graph now goes like this. And so up to a, the upper one is the root minus the lower one is the x squared, or the ax squared. But between a and 1, the upper one is the ax squared, because we're wanting this area, and the lower one is the root x. So we now need to split this integral to between 0 and a, and then a and 1. All right, so split that integral, and so we need to go between 0 and a, and that's where the root is on top. Actually, I've made an error here. Let me just, it's not 0 and a, that's not our a, that value there. Our a has to do with the intersection, of course. Sorry, so our point of intersection. So that's not a at all. Our point of intersection between root x and ax squared, all right, is of course then that a would be root x on x squared, and that would of course would be then half minus 2 x to the minus 3 on 2. So that then means that the x value in terms of a would be a to the negative 2/3. All right, so I made a bit of an error there with that. So I made a mistake in my notes on I drew my diagrams. So this x value here is related to a, and it's a to the negative 2/3. So my limits is then, that's then a to the negative 2/3. And then the next one is from a to the negative 2/3 to 2. And that's when our ax squared is on top, minus root x dx. And then we get our, and then that of course is equal to 1/3. And we get our calculator again to solve that. And when we get our calculator to solve that, you get 1.13. All right, so hopefully that little error that I made hasn't confused you. All right, because it's that point of intersection here is what we're wanting, which is this information over here. All right, and so the x needs to be in terms of a, but it's not a. All right, so again, careful with your calculator, because it's very easy to make errors with the calculator of what you're doing here. So, you know, get your teacher or someone or some online thing to give you a hand about how you might go using your calculator. Be careful with that. So some of these integrals you might need to simplify them so that your calculator can handle them. And I think that's about it. Of course, make sure you talk to your teacher, get your teacher's opinion on things, and also don't forget, you know, examiners' reports as well. All right, further questions got their own videos, and I think that's it for this one.